In this video, I'm going to show you how to solve a quadratic equation by factoring. Notice it says here a quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. Call that the standard form, where a, b, and c are real numbers and a does not equal 0. In order to be a quadratic equation, it needs to have an x squared in it, and that's going to be the highest power, and that's what makes it quadratic. So if a were 0, there would be no quadratic equation. It would actually be linear. So let's go ahead and get started. Notice it says we use the idea that if a times b equals 0, then either a or b must equal 0. So basically the idea is if you multiply two numbers and you get 0, one of them must be 0. That's the only way you can get 0 when you multiply numbers. So let's look at number 1. I've already done an example here. So you can see we have x squared plus 3x minus 10 equals 0. And when you factor that, since it's a trinomial, you should use the AC method or whatever method you use. And so now notice we have two factors that multiply to 0. So one of these factors must be 0. Either x plus 5 is 0 or x minus 2 is 0. And so we get x equals negative 5 or x is equal to 2 when we solve those two equations. Whoops, let me fix that real quick. Alright, so I just want to mention a lot of times in college algebra textbooks they want you to write your answer as a solution set. So for me it's okay to write it the way I did here, but you could also write your answer in this form, and we call that the solution set. Alright, so keep in mind that's true for any of these. Normally we're getting two answers and we write our answer as a solution set. I don't care which way you do it. Let's go ahead and look at number 2. So first of all, if you look at these two terms, they both have a 3x in common as a factor. So our GCF here is 3x. In fact, when we're factoring, that's something we should always look for first. So let's go ahead and factor out the 3x. We've got two terms here. 3x times 2x should give us the 6x squared. And we need something times 3x that gives us a minus 3x. That would be minus 1. And so here we have two things. We could think of this as two things that multiply together and give you 0. So we'll set each of those equal to 0. 3x equals 0, x has to be 0 there. On the other one, if you add 1 to both sides and divide by 2, you get 1/2. And so those are your two solutions to number 2. Now when you look at number 3, I hope it immediately jumps out at you that this is a special form. X squared minus 25. This is a difference of squares. So with the difference of squares, we know that we're going to get the same numbers in our binomials with an opposite sign in between. In this case, it'll be x minus 5 times x plus 5. And so you can set each of those equal to 0, and you're going to get 5 and negative 5. Oh, I just wanted to point out here that the x minus 5 being a factor, you could actually skip that middle step. After you've done these a few times, you realize that just means x is going to be 5. And when you see x plus 5 as a factor, you know that x equals negative 5 will be a solution as well. In fact, you can easily see, like for example with the 5, if you plug it back in right here, whoops, putting a 5 in there, you get 5 minus 5, which is 0. 0 times anything is going to be 0. And so you can see that that would work. All right, let's go on to number 4. So notice I need to get everything on one side, 0 on the other side, get it in this standard form. And on the left, there's no like terms, so I just want to write them in what we call descending order. X squared, then the x term, then the constant. And on the other side we have 0. So here we're going to need to use the AC method, or if you have another method you use, that's fine. This is a trinomial that needs to be factored. So AC here is 2 times 21, or 42, and our b term is negative 17. So we need two numbers that multiply to 42 and add up to negative 17. So these are all my factors of 42. I also know that when I multiply two numbers, if I get a positive, they must both be positive or both be negative. Since these numbers need to add up to a negative number, negative 17, they must both be negative. So you can see the one that works is negative 3 and negative 14. So negative 3 times negative 14 is 42, and negative 3 plus negative 14 is negative 17. So let's go ahead and split our b term into a minus 3x and a minus 14x using those factors we just found. And we can now factor by grouping, so we can factor out an x in the first two terms. We get x times 2x minus 3. We also know if we get a 2x minus 3 here, that's what we're expecting to get for our other factor. And you can see to get a minus 14x, I need a minus 7 in the middle. And notice negative 7 times 2x is the negative 14x, and negative 7 times negative 3 gives you the 21. So this is good. And so now we know that's 2x minus 3 times x minus 7. For some people, they just cross these out, and you can see the x minus 7 is your other factor. So we'll set 2x minus 3 equal to 0, and we're going to get 3 halves there, and then 7 will be our other solution. So I'm going to go ahead and write this as a solution set, and it would be negative, or 3 halves and 7. All right, let's look at number 5. Now you may be tempted to just jump into doing it the same way we just did the last one, but notice we have a greatest common factor of 2. And so let's go ahead and factor out a 2. And if you have 2 times this trinomial equal to 0, well, it's not because of the 2. X squared minus 7x plus 10 must be 0. So we're going to solve that. And again, we can use the AC method. It's 3 terms. Need 2 numbers that multiply to 10 that add to negative 7. And negative 2 and negative 5 are going to work. So let's plug those in. Factor by grouping. We can factor out an x times x minus 2. I know I'm going to get an x minus 2 for the other 2 terms. And I need a minus 5x there, so it's going to be a minus 5. And if you distribute, you can see that that does equal the 5x minus 10 here. And so we're going to get x minus 2 times x minus 5 is 0, which means our solution is going to be 5 and 2. Now I want to point out something here. If you don't already know this, there's actually a shortcut for a situation like here when you've got a 1 in front of the x squared. Notice the numbers that we found, negative 2 and negative 5, and right here we had x minus 2 and x minus 5 when we got this factored. So it turns out that anytime your coefficient of x squared is 1, you can take this shortcut. So we can go directly to x minus 2 and x minus 5. We really didn't have to do these 2 steps here. They're kind of optional steps in this case. Now if you look back at number 4, that's not an option there because we had a 2 in front of the x squared. All right, let's move on to number 6. So we'll subtract 45 on both sides to get this in standard form. And let's see, we can use the AC method. And we need 2 numbers that multiply to negative 45 that add to negative 4. And the numbers that work are negative 9 and 5. And notice this is 1x squared here. And so I can just plug in a minus 9 and a plus 5 into these binomials here. You can always check it by foiling and verify that this is true. So again, we can take the shortcut here. We don't have to do those 2 steps like we did over here. So we're going to get 9 and negative 5. And that's going to be it for this video.